Now, dancer rolls, there's a lot of different types of dancers. I'm going to cover pivot arm type. We're going to talk about linear dancers and rotational dancers. And they all work, again, on a common principle. Basically, dancers are all loaded in one direction. And in order for a dancer roll to work, the web has to have a tendency to move them in the opposite direction that they're loaded. There's a sensor that detects the dancer position, and the control looks at the dancer position and tells a torque mechanism to either add or subtract torque to keep the dancer in a constant position. That's how closed-loop dancer roll tension control systems work, basically. And remember that as long as your dancer is within its travel, as long as it's not bottomed out in one direction or the other, as long as it's not up against one of its stops, you have constant tension on your web. As long as the dancer, even if it's not always in the same position, as long as it's somewhere within its travel, you will have constant tension on your web. And another thing to remember about dancers, they all have some amount of web storage. So they are very mechanically stable. I'm talking about mechanically stable, so they can control drives. They can very easily absorb tension fluctuations. So if you have that unplanned tension change, let's say we're bearing stick, a dancer will compensate for that like a shock absorber. And you may see, if you put your hand on the web as it's flowing, you may feel tension fluctuations going into a dancer, but on the output side of the dancer, if it's operating properly, you'll have a nice constant tension coming out of the downstream side of the dancer. This is an example of a pivot arm type dancer. Basically, your web is fed through, usually is like a 180-degree wrap angle around that the pivoting roll, but it could be less, could be more, but you'll see this type of application quite often with that type of wrap angle. And you can see that this air cylinder is loading the roller in this direction. And as you apply tension to this web, let's say you were to hold the web back here and pull it out, the web is going to have a tendency to lift that roller up. So this sensor senses the position of the dancer in its travel, and anytime this dancer moves, the sensor tells the control to change torque output to whatever drive device you have. So whether you have a brake on an unwind, let's say you have a brake on an unwind going through a dancer, as any tension changes, the dancer is going to move slightly, and the control is going to tell the brake to decrease torque, literally as the roll diameter is getting smaller. On a rewind, it's just the opposite, as we talked. And in internal zones, if there's any tension fluctuations due to, let's say, out of round bearings again, the dancer will move slightly in one direction or the other, and that sensor will see that movement, and this control will tell the drive mechanism to make a change, to keep the dancer always in a constant position. This is one of the simplest type dancers. It's by far the most common design that you'll see most dance rolls designed this way. It's one of the least expensive dancers, and they can be designed with a small or a large amount of web storage depending on what you need for your application. Some disadvantages, gravity is always a concern with this type of dancer. Just going back to the previous slide, not only do you have the loading of the cylinder on the dancer, but you also have the weight of this dancer. So that has to come into play in terms of designing the dancer. You have to consider how much weight of this assembly is also in addition to this air cylinder in terms of loading your web. So gravity is always something you're fighting with this type of dancer. They are bulky. They do take up a lot of space in your machine. Momentum and inertia with all dancers is always a concern because a body in motion wants to stay in motion. So in other words, once the dancer starts to move a little bit in one direction or the other, it wants to keep going in that direction, and that can cause some tension fluctuations on the output side of the dancer.